Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to inverse variation, the reciprocal function. Before I get into what inverse variation is, I probably feel like I need to go back and refresh your memory on what direct variation is. Direct variation, we see it everywhere in our life. So direct variation would be like your paycheck, assuming you're an hourly paid. Okay, it might be your cost at the fuel pump. Okay, for example, you work 0 hours, you get work $0. You buy 0 gallons, you pay $0, right? Or you might work 1 hour and you might get paid $15. Or you might pay for 1 gallon and it costs you $2.75. Depends on what the cost is that time. That's your constant of variation. I use a K value for constant of variation. K might be your pay per hour. It might be your cost per gallon. If you're buying, say, bottles of water or soda, it could be your cost per bottle, right? So it's basically how much it would cost for one. And these always come in the form y equals k times x. There's no plus, there's no minus, because it's a direct relationship. As your independent variable goes up, your dependent variable also goes up. If your independent variable were to go down, your dependent variable would also go down. So keep that in mind, that direct variation, they go together, okay? They usually, if you were to graph them, they graph as a line, because this is linear. But our focus today is not on direct variation, it's on inverse variation and the reciprocal function. So if direct variation is one goes up, then one goes down, then what is inverse variation? This is like as one goes up, like they're going in opposite directions. Okay? So think the further you drive, so more miles, the fewer gallons remain in your tank. Now I know you can go fuel up again, but then it starts it over, right? As the temperature drops, your heat bill goes up. Right? As one goes down, one goes up. So instead of y equals k times x, these are going to be written y equals k divided by x. And so directly is multiply, inversely is divide. Okay, inverse is kind of the reciprocal, right? Hence why it's the reciprocal function. So we're going to look at a couple of options. I'm just going to give us a couple charts. Okay, sometimes they'll give us charts vertically, sometimes they'll give us charts horizontally. Okay, is this an inverse variation or direct? I mean, you could also think direct, but x is getting bigger and y is getting smaller, so it could be an inverse. Okay, so y equals k divided by 12. On the first one, y equals, I wrote 12 already, forgive me on that. This is k over x. 12 equals k divided by 1. So in this case, k would equal 12. because 12 divided by 1 is 12. Okay, let's check here. Y equals something divided by 2. Hey, that's also 12. Does 12 divided by 3 is 4. 12 divided by 4 is 3. Hey, the k value works for all of them. That k value is 12. So yes, this is an inverse variation. And so we can write our equation, y equals 12 over x. Perfect. Just so that you've seen it here, sometimes they save vertical space by writing horizontally. Okay, so x is increasing and y is decreasing. So is it an inverse function? Well, let's check. Again, anytime we're checking for inverse, we're saying does y equal something divided by x? So 20 would equal something divided by 1. So in this case, 1 times 20, 20 would be our k value. Okay, 17 would equal k divided by 2, times that over, 34 would be our k. Ooh, that's not the same. So no inverse variation. It doesn't mean that these are not related. It's just not an inverse variation. It happens to be, just so you know, y equals negative 3x plus 23. It happens to be linear. Now, this plus 23 is why it's not direct either. Because direct variation can only be y equals k times x. You don't get any plus either. So this one is either neither direct nor inverse. It has a relationship, it's just not one of our two special relationships. Okay. So x and y vary inversely. If x equals 10, when y equals negative 2, find y when x equals 5. Okay, I find students just read this all way too quickly. And they just try to get like to the end, and it just doesn't work so hot. So what we need to do is we need to read this in pieces. X and y vary inversely. Okay, because of that, I'm going to write this. Because that's what inverse variation means. Y equals something divided by x. Now, I'm going to put this together, and I'm going to put this in that statement. Negative 2 equals k over 10. And then I'm going to write this. Y equals k over 5. So I substituted the brown and the pink into the green. Well, the brown step is going to help us find out what k is. Because when I multiply by 10, I find out negative 20 equals k. Now that I've done that, I can substitute the brown k value into the pink equation. And I find out that k divided by 5 will give us our y of negative 4. So we can do those in steps. So keep in mind that every time you come to a punctuation mark of any kind, pause, write something down. The best way to do math word problems is to pause every punctuation point and write something down. Okay, so what is this going to look like graphically, things like that, because obviously I'm using graph paper for a reason. And direct variation, you know, is a line, but what is this inverse variation going to look like? So we're going to look at the basic parent function. And we can apply HK shifts that we've talked about in other videos once we understand the basic parent function. So our k value is going to be 1 for a basic parent function. Now, if a power winds up on here, it changes everything, so keep in mind this is just y equals 1 over x to the first power. So the first thing is I'm going to look at a table of values. We're going to look at some positives, and then I'm going to look at some negatives. And I'm going to do them on two different tables, not because they're two different graphs, I don't want to run super tall on my page. So substituting 0. Type 1 to 0 divided by 0 in your calculator. Your calculator is going to say undefined. If you have one item, there's no way to divide it into 0 pieces. It just doesn't happen. Okay. I saw one of my friends put 0 divided by k is okay. Number divided by 0 is no, cannot do. So think about that. Or they did 0 divided by n. That's what they did. 0 divided by n, game on. Number divided by 0 was no. They didn't use k. They used 0 and n. So 0 divided by n, game on. N divided by 0, no way. So we cannot do 0. There's a big issue at 0, and it's going to show on the graph. If I put in 1, 1 divided by 1 is 1. I know I skipped a space. If I put in 2, I get 1/2. If I put in 3, I get 1/3. Ooh, this is interesting. What if I put in 1/2? 0 divided by 1/2 is 2. Forgot I actually wanted this over here for fractions. What about 1/3? 1 divided by 1/3 is 3. Okay. One-fourth would be 4. 1/5 would be 5. This is interesting. Okay. So 0 we couldn't do. 1 was at 1. 2 was at 1/2. 3 was at 1/3. 4 would have been 1/4. Okay. 1/2 was at 2. 1/3 was at 3. 1/4 was at 4. Okay. Will this ever actually get to 0? Well, 1 divided by 100, that'd be 0.01. 1 divided by 1,000, 0.001. 1 divided by 10 to the 7th is going to be 0.1, 2, 3, 4, 5. Still not 0. It's going to continue to get, if I could do 1 divided by 10 to the 100th. That's a really big number, right? And I would get 1 times 10 to the negative 100th. That's a lot of decimal places. That's very tiny, but it still exists. And that's what's going to happen is because we are starting with, like, think of an entire pizza. You start with a pizza and you split it into a bunch of parts. Well, if you have to share one pizza with 100 people, everyone's going to get a little bit, but not very much. And then there's still the crumbs left on the tray. So you say it's gone, but it's not really gone. That leads us to an asymptote. There is a horizontal asymptote here at y equals 0. Why is it a y equals? Because any flat line is going to cross the y-axis. They have different x values, but their y value is always the same. This is what's known as a horizontal asymptote. The entire point of an asymptote is to approximate end behavior. Ends are your arrows. And as you notice, we're getting closer and closer and closer to a y value being 0 at this arrow right here. Okay, well, what about right here? See how it's going, it's shooting up, but our x value is also getting closer to 0. And we have indeed a vertical asymptote as well. And the reason for this vertical asymptote is the domain error, because that's where we're undefined. Okay, so, but I only tried positive numbers. Instead of redoing the chart, what happens if I divide by -1? I get -1. 1 divided by -2 is -1/2. 1 divided by -3 is -1/3. 1 divided by -1/2 is -2. See how it's the same ordered pairs? They're just, when you put a negative in the denominator, you get a -y. So because of that, we're getting a very similar shape, but now instead of quadrant 1, it's in quadrant 3. Okay, so as you notice, over here, x is going really far to the left, to -infinity. And our y value is getting closer and closer and closer to 0. Now you might sometimes see a sign after it. That would be because it's getting closer to 0, but it's slightly below 0. So they put a negative sign after the 0. Over here, x is getting really big and y is getting closer to 0, but it's slightly above. So that would be positive. So this is your direction approach notation for that arrow. This is your direction notation for that arrow. And it doesn't matter whether you go left to infinity or right to infinity, your y is closing in on 0 in both directions, hence why we have the horizontal asymptote. Okay? The other thing you think is, the further I go out, the closer I get to 0. Now, what about when I come in? When I get closer to that vertical asymptote? So when you're approaching 0, but you're on the left, see how now it's a left-right instead of an up-down? Your y is shooting straight down. It's going deeper in the hole. And up here, when you get closer to 0 on the right side, though, because we're on the right side of 0, our y's are skyrocketing. Now, fun thing. If you were to try to trace the graph and go to 0, notice how your fingers don't come together? If you've ever watched the movie Mean Girls, this is an example of the limit doesn't exist. In order for the limit to exist, your fingers would have to meet at that value. But at 0, since they're going in opposite directions, the limit at 0 does not exist. So that's just a fun thing. At 0, limit does not exist. So we have a vertical asymptote and a horizontal asymptote. Now, asymptotes are indicators of end behaviors. You can cross asymptotes. Okay? Vertical asymptotes are domain errors. And approximation of end behavior. So you will never cross them. Horizontal asymptotes are just approximation of end behaviors. And you can cross them. So just so you understand what I'm saying, I have seen graphs that have a horizontal asymptote like this, and yet the graph itself did this. So it crossed here in the middle, but still it has a horizontal asymptote at 0. So there are some weird graphs out there. You can cross a horizontal one. The whole point of an asymptote is to indicate end behaviors, or your arrows. That's technically extra, but just in case you were curious. All right, coming back up here. I'm going to regraph this just a little bit so it looks, there's a lot of information on that picture. I like to put my asymptote in a different color than my graph, so I remember it exists, and I always draw my dotted lines. Okay. So when you have graphs that have asymptotes, you have to be careful with your domain and range. Okay, so for our domain, we're going along, we're going along, we're going along, we're going along, we're going along. Then we hit that asymptote, and there's no dot up on this line, so we have to pick up our pencil, and then we get to go along again. So our domain is everything, but we skipped 0. So x is anything between negative infinity and 0, parenthesis, because we didn't use include 0, or 0 to infinity. And our y's kind of did the same thing. It's coming this side, we're coming up, coming up, coming up, coming up. We hit that asymptote, and there's no dot horizontally anywhere on that asymptote, so we skipped over it, and then we continued on. So in this case, our range was very similar. Oh, I forgot the element symbol. Y is an element of negative infinity to 0, or 0 to infinity. So let's try to use what we know. And if you've watched my other videos, you know I've done a lot of HK shifts, and this is going to hold true still. So f of x is going to be 1 over x minus 3 plus 4. Okay, so focus. Even if your problem doesn't have parentheses around the denominator, there's understood parentheses around the denominator. So if you remember correctly from previous videos that f of x minus h plus k, so we have a minus 3, which means it's a horizontal translation. Oh, video, come on. 3 right and up 4. But if I took away all my numbers, this would just be 1 over x. So this is the shape we're using, but we're just shifting it 3 to the right and 4 up. So I've traced it very lightly here. Okay, that was our graph for 1 over x. And we had this asymptote. We had this asymptote, right? Well, our asymptotes are going to move as well. So instead of my vertical asymptote being at 0, it's going to go 3 to the right. It cuts through x equals 3. And then 4 up. And your asymptotes are great guidelines for helping you graph. Okay. So this was over 1, up 1, so over 1, up, well, 1, 2, 3, 1, 2, 3, 4, check. from here. 1, 2, 3, 1, 2, 3, 4. Yep. And then we had those guidelines. And then just because the paper's a bit messy, it happens. There's our coordinate plane for our x-axis and our y-axis. So now domain and range. X, we come along, the only x value we skip is 3. So our x is from negative infinity to 3, or 3 to infinity. And our y's, now this was a domain error because you can't divide by 0. And if I substitute 3, that would be 1 divided by 0 because 3 minus 3 is 0. That's why we skipped 3. And it looks like vertically we skipped 4. So negative infinity to 4, or 4 to infinity. You might ask yourself, well, every time you've done a 1 as a numerator, what happens if you have a number besides 1? Let's say you have f of x equals 2 over x plus 5 plus 1. Well, this is the same thing as 2 times 1 over x plus 5. Again, technically parentheses. So because of those parentheses, we do that first. Left 5, because that's the h value. And if you remember, a multiplier value is a stretch value. Stretch by a factor of 2. So it's going to climb quicker. That's what's going to happen. And then the plus 1. And that's going to shift it up 1. So if you're taking an algebra class for high school math, seeing the HK shifts is going to be a big key component. If you're working in a college algebra class, you probably have a graphing calculator and that will help you see it. If you get stuck, make a table of values. However, I always utilize my H shift as the center of my table of values. That way I don't miss key points of the middle of the graph.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.